Recording.
Okay, children, now I'm going to discuss 2025 May-June paper, Unit 1. So I decided to do some of the papers like that. So at that when I do this YouTube video, so then you can see at any time that you want. That is what the purpose. Now we quickly go to the first question in 2025 May-June paper. I will show you the paper. So this is for the paper 2025 May-June. The first question that we are going to discuss, which row shows the number of neutrons and electrons in a bromide ion? So that is the question, which row shows the number of electrons and neutrons in the bromide ion? So they say it is Br minus 79 and 35. There are 35 protons. That means there are how many electrons? Should be 35. For this minus charge, there's another one electron. So total number of electrons is equal to 36. And number of neutrons, how do we find this? This minus this is the neutron, so that is 44. So how many neutrons and how many electrons? Neutrons 44, electrons 36. The answer is B. The answer for that is what then? The answer is B. So that is the answer for the first question. That is very easy one. Now we will see how the answer comes for the second question. Right. Now let me show the second question. See, this is for the second question is, what volume of sulfur dioxide gas reacts completely with 50 of 0.12 moles per cubic decimeter sodium hydroxide solution? And the equation is given. You see that mole ratio between sulfur dioxide to sodium hydroxide is 1:2. Okay, now we go to this question, then how we get the answer for that. That is, it's something like this way. Now they have given you the balance equation between the sulfur dioxide. They have given you the balance equation between the sulfur dioxide and sodium hydroxide. So the sulfur dioxide and sodium hydroxide NaOH, that it gives what? Na2SO3 plus the other one is water. So this is what the reaction, and when we want to balance it, it's 2 sodium hydroxide, so the mole ratio is 1:2. Mole ratio is 1:2. So when I concern this sodium hydroxide, the set of information given in the sodium hydroxide, you know the volume of the sodium hydroxide is given clearly, that is 50 centimeter cubes, and you know the concentration of the sodium hydroxide is given clearly, that is 0.12 moles per decimeter cube. So then now we will find the number of moles of sodium hydroxide. You know N is equal Cv, so N is equal Cc is 0.12, V is 50, is centimeter cube, so decimeter cubes. To convert to decimeter cube, we divide that by 1000. So 0.12 multiplied by 50 and divide by 1000. The answer is how many moles there? 0.006 is there. That's the number of sodium hydroxide moles, 0.006. So the sulfur dioxide moles should be half of that. should be half of that because 1:2. So the sulfur dioxide mole is 0.03. So then sulfur dioxide volume, how to find that? Volume is equal moles multiplied by 24. This equation is used in the gaseous samples to find the number of moles. Volume, to find the volume, mole should be multiplied by 24. You know that the number of moles 0.03, volume is what, 24. So then 0.03 multiplied by 24, then answer is what? So we see that 0.0, we see that 0.0, it should be 0.003, 0.003 multiplied by 24. The answer is 0.003 multiplied by 24. The answer is 0.2. The volume is how much? 0.072 is the one. Clear? So then the answer is this one. So we get the answer that answer for the second one is the answer A. Answer for the second one is the answer A. So we go to the next one, the question number 3 in our paper. So that is the question number 3. Now we see the question number 3. Right. I'll show you the paper. I'll show you the paper. What amount does not have the mass of approximately 6 grams? Which amount does not have the mass of approximately 6 grams? The correct answer for this one, we will see that which amount does not have the mass of approximate 6 grams, does not have the mass of approximate 6 grams. So that is again quite easy one. We see this one, which amount does not have the mass approximately 6 grams. So now if I concern the mass is equal moles multiplied by molecular mass. You know this equation. So if I go to the answer for the answer A says number of moles equal 0.33 multiplied by molecular mass is how much it is? 18. How much it is? 18. And then so when we concern this one, 0.33 multiplied by 18, so then our answer is 5.94. So it is almost close to 6.0. We can concern it is almost close to 6.0. And answer B, the B is mass equals moles into molecular mass. So the mass is equal moles. How many moles of magnesium? 0.25 moles of magnesium. Molecular mass of the magnesium is given 24.3. So that is 24.3. The mass is equal 0.25 multiplied by 24.3. So the answer is 6.075. So that also we can say approximately equal to 6.0. So the A answer gives the 6 grams, B answer gives the 6 grams, and when I go to the C answer, that is mass is equal moles into molecular mass. So then moles they have given 0.033. Molecular mass is how much? 180. So we concern 0.033 multiplied by 180. So then again the answer is 5.94, approximately equal 6.0. And the next one, D1, so that is mass equals moles into molecular mass. Mass is moles is how much? 0.025. Molecular mass is how much? 159.6. So then the answer 0.025 multiplied by 159.6. So it is equal 3.99. So this is not equal to 6 grams. So the answer is D. The correct answer is D. I guess it is clear to you how we get the answer for the D. Right. Now we go to the next question, that is question number 4, I guess. So we see that what is question number 4 is. Now you see the question number 4 is this one. How many molecules of water are present in a 1 drop of water? So they have given volume of 1 drop and they have given density of water also. Right. So we see then how to find the answer for that. They have given the volume of 1 drop of water. They ask how many molecules of water. How many molecules of water? Right, they ask how many molecules of water. So they ask how many molecules of water. We find the first moles of water. Early before that we will find the mass of water. We go in order. Mass of water. Mass of water. Mass. We find the mass here from the density, like in a physics. Right, you know the density is equal mass over volume. So then we can say mass is equal density into volume. Right, mass is equal, so we can say the mass is equal density into volume. The mass is equal density. Density is given. What the density of water? A density of water is 1. Volume also given. Volume is how much? 0.05. So then the mass we can find what the mass of that is. 0.05 grams of water. So I know the mass of water. So I will find the next one. Moles of water. Moles of water. How to find the moles of water? Moles of water. Moles equal mass over molecular mass. Moles equal mass is how much? 0.05. Molecular mass of water, you know that is 18. Right. So then n is equal 0.05. N is equal 0.05 divided by 18. How many moles are there? 0.00277 moles are there. This number of moles are there. That is the number of moles. They ask molecules. Molecules. So how do we convert moles into molecules? When we convert moles into molecules, mole should be multiplied by Avogadro's number. Mole should be multiplied by Avogadro's number. So when I multiply moles by the Avogadro's number, we get the molecules. 0.00277 is the moles. Avogadro number is 6.02 into 10 to the power 23 into 10 to the power 23. So that is 0.00277 multiplied by 6.02 that thing. So the answer is 1.67 into 10 to the power 23. So into 10 to the power 21 into 10 to the power 21. So the answer is D. Right, the answer is D. So you get how to get the answer for that. Right, so that is the way we get the answer for the question number 4. Now we quickly go to question number 5. Right, we see what is the question number 5 is. Question number 5 is this one. Which mass of fertilizer contains 467 grams of nitrogen? Which mass of fertilizer contains 467 grams of nitrogen? So we find that which mass of fertilizer contains 467 grams of nitrogen. 467 grams of nitrogen. See this one. Okay, now we go to this one. Which mass of fertilizer contains 467 grams of nitrogen in see this one. I will go to the first answers. First answer we will discuss about the first answer. There are 2 kilograms of sodium nitrate. Sodium nitrate, NaNO3. Right. Sodium nitrate. There are 2 kilograms of sodium nitrate. So how do we work with that? 2 kilograms of sodium nitrate. So when I concern the mass of nitrogen here, mass of one nitrogen there, therefore the mass of nitrogen is 14. Total mass, sodium 23, nitrogen 14, oxygen 16 into 3, 48. Oxygen 16 into 3, 48. So now this is the mass of nitrogen, this is the total mass. So for this total mass, 14 grams of nitrogen there. Right. Now for an example, that is 14 plus 20, 14 plus 23 plus 48, that is equal what? 85. So here 14. So out of 85, 14 grams is nitrogen. So if I take 2 kilograms, 2 kilograms means how many grams? 2000 grams. So for 2000 grams, how much? Then that is 14 divided by 85 multiplied by 2000. So it is 329 grams. I got 329.4 grams is the answer. Now we want it should be contains 467 grams of nitrogen. So A is wrong, then A is not the answer. Now we go to the next one. B is urea. Urea, they have given the formula of the urea. NH2. Urea is NH2, CO, again NH2. So this is what the urea is. How many nitrogen there? 2 nitrogen. So 14 into 2. Total mass is how much? 14 into 2 plus carbon 12, oxygen 16. How many hydrogen? 2 and 2, 4. Right. So then up it is 28. Below how much? That is 14 into 2. 14 into 2 plus 12 plus 16 plus 4, that is 60. So what about 1 kilogram? 1 kilogram is 1000 gram. So that should be this way, 28 divided by 60 multiplied by 1000. The answer I got is 466.666 like that. So that is the answer. So we can say it is 467. We can round off it like that. The answer is B. I guess you understood how to get the answer for that. Right. Now I go to question number 6. Question number 6. See that question number 6. What is question number 6 is question number 6 is this one. Which is the correct order of the process in mass spectrometer? Which is the correct order in the order for the processes in mass spectrometer. So which is the correct order in the processes? So now we got this one. The correct order in the processes, you know, in the mass spectrometer, the process of mass spectrometer, what first happens in the mass spectrometer, what first happens is vaporization, next ionization, next acceleration, next deflection, the next detection. So vaporization, ionization, acceleration, deflection, detection, those are the steps takes place there. So when we concern this which is the correct order for the process in the mass spectrometer, which is the correct order for the process occurs in the mass spectrometer. First one says answer A, it is deflection. It cannot happen the deflection there, right? The correct answer is, but first vaporization, next ionization, next deflection, and next detection. The answer for the sixth one is B is the answer for the sixth one. That's quite easy question. Now we go to the question number 10. Now we go to question number 10. So we see how the question number 10 works. Sorry, we have to go to question number 7. So we see how the question number 7 works. Right. Which of these molecules are polar? They are asking about the HCl molecule, BeCl2 molecule, and BCl3 molecule. Which of these molecules are polar? Hydrogen chloride, beryllium chloride, and boron trichloride, BCl3. That is our 7th question is. Okay. Now we see that question number 7. How works with that? These are the 3 molecules, HCl, beryllium chloride, and BCl3. Right. So the polar molecule, if you concern HCl molecule, hydrogen is less electronegative, chlorine is more electronegative. So all the electrons go towards the chlorine. So towards the chlorine delta minus, hydrogen delta plus. There's a electronegativity difference. Chlorine is more electronegative. So then delta minus, hydrogen delta plus. So that is polar. But when I consider the BeCl2 molecule, if you remember, BeCl2 is a polar molecule. So how strongly this chlorine, BeCl2 is a non-polar molecule and it is linear molecule. How strongly this chlorine takes the electrons, same strongly this chlorine takes the electrons. So the electrons in the middle go that side, same strength this side. It's something like here there's a ring, this side 10 Newton, and this side also 10 Newton, this side also 10 Newton. So what will happen? Ultimate result is the ring is not traveling any side, like that. This BeCl2 molecule, this dipole moment cancel off by this dipole moment. So net dipole moment cancel off. This is not polar. So we got this one, BeCl3. So that is also same way. So you can see that. This chlorine attracts electron, the other two opposite. This chlorine attracts electron, the other two opposite. So net dipole moment cancel off. If there is 10 Newton to this side and 10 Newton to this side and 10 Newton to this side, like in a physics. So the ring is not moving any side. Similarly, here the dipole moment cancels, so this is also not polar. Only one polar molecule is there, that is HCl. So the answer is first one, A1 only. The answer for this one is the answer A. Right. Now we go to the question number 8. So in question number 8, which substance does not exist as a giant lattice? Which substance does not exist as a giant lattice? Which substance does not exist as a giant lattice? Silver, it makes a giant metallic lattice. Right? Silver. The other one is sodium chloride. The other one is graphite. The other one is Buckminster fullerene C60. You know, silver is a metal, so it makes a metallic lattice. Sodium chloride is ionic compound, so it makes an ionic lattice. Graphite makes giant covalent lattice. Fullerenes are not making lattice. The answer for that is D. Right? The answer for that is D. So the answer is Buckminster fullerene, that they are not making lattice. Fullerene is a molecule only. Now we go to question number 9. Which method of the preparation of hydrogen has the highest atom economy? Which one has the highest atom economy? So we find the one it has the highest atom economy here. So now we will see how to get the answer for this one. Highest atom economy, which one of these has the highest atom economy? So first of all, you need to remember what is the equation for the atom economy. There's an equation for the atom economy. You need to remember the equation for the atom economy equation. So we see that. What is the equation for the atom economy? Right. This atom economy is equal mass of atoms of desired product. Right. Mass of atoms of desired product. I write dP for the desired product, divide by mass of atoms of all products, multiply by 100. So here, which of the method for the preparation of hydrogen has the highest atom economy? Highest atom economy is the highest atom economy by mass. The highest atom economy by mass. Right, we see which one has the highest atom economy by mass. It's like this way. So we can write atom economy is equal mass of the atoms of desired product. First one, mass of the atoms of desired product. You see how much of hydrogen produced? It produces 4 hydrogen, right? You see how many hydrogen produced? The first one, it produces 4 hydrogen, so 4 grams, because that's the desired product. And the next one, mass of the atoms of all the products, then the 4 grams, and oxygen, so how much? 32 multiplied by 100. The answer is 11.1%. So then this is the first one. A answer is 11.1%. So we go to the B answer, right? We go to the B answer. See the B answer. Hydrogen mass is 6, because 6 hydrogen atoms, so 3 moles are there. 6 hydrogen atoms totally, so mass is 6. And here 6 plus carbon 12, oxygen 16, multiplied by 100, right? Multiplied by 100. So then the atom economy for that. So 12 and 16. So we will find this one. 6 divided by 6 plus 12 plus 16. So it is 34 multiplied by 100. So then it is 6 divided by 34 multiplied by 100. So that is 17.6%. That's the answer for the B. Now similarly, if you count that for the C1, C1 hydrogen is only 2 divided by hydrogen 2 plus 44 multiplied by 100. So that atom economy is 4.35. So then I got the D answer. Answer D. D is 6 divided by 44 into 100. So the answer is 12%. So then the highest atom economy is given by 17.6. So the answer is B. That is the answer. So you know how to get that. Now we will continue the next set of questions with another video. Thank you.